with the k value of as like 1 or 2 or 3. So in this case, let's assume we start with the 2. And how did we arrive at this value? This will help us determine which centroid each point belongs to. Of all the points in the specific cluster, whether it is red or green. Okay, so this is necessary because we need to update the centroid to reflect the new location of the point. Let me introduce with it. So in our example, we are going to have 8 data points: A1, A2, A3, B1, B2, B3 and C1, C2. Applying this rule to all the data points. So here we just got the first cluster assignment. What is next? Of course, we have to calculate the distance between these data points towards the centroid of each cluster. And kindly just observe, dear friends. Let I just place the exact value of this. So in such a case, if we might notice the sum point changes, of course, we have to repeat it again. That's how the k-means algorithm using Euclidean distance works, by repeating these steps until cluster stabilize. Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, today we are going to discuss about k-means clustering. In unsupervised machine learning, clustering is the most important thing that revolutionized machine learning. Clustering involves grouping similar data based on different features. There are various techniques for clustering, and one of them is known as k-means clustering. Dear friends, this technique involves plotting data and grouping them into cluster based on their similarities. In unsupervised machine learning, clustering is the technique used to group similar data. So the goal is to create cluster based on different data inputs without any specific output in mind. So one of the popular way to cluster data is through k-means cluster. Dear friends, when clustering a custom ensemble model, we usually start by clustering our data set. This involves applying a clustering algorithm to group our data into 2 or 3 separate clusters. Once we have our cluster, we can apply a regression or classification algorithm to each group to solve a specific output. So to understand this process better, it's important to focus on how the k-means cluster algorithm works. And dear friends, here, of course, when we just specify k, it means how many cluster you have. And if you have 2 groups as like this, okay, then the k, it would be 2. And dear friends, each cluster, each group has a centroid. If we have a data set like this, kindly just observe in this picture. So we can easily see that there are 2 separate groups because there are 2-dimensional data. However, remember that real world set will have much more complex due to high dimensionality. Then you will see the data plotted. Now, how do you conclude that only 2 groups are there? For that, we have to follow few steps. Dear friends, first of all, we need to experiment the different k. Okay, so the k value. We can achieve this by testing various centroid. So until we find the appropriate k value. Okay, so assuming we have a particular data points, we can start by testing with the k value of as like 1 or 2 or 3. So in this case, let's assume we start with the 2. And how did we arrive at this value? The within cluster sum of square is a measure of the variability of the observation within each cluster. And here in general, a cluster that has a small sum of square is more compact than a cluster that has a large sum of square. Different clusters that have higher value exhibits greater variability of the observation within the cluster. And here, in this case, we are working with 2 centroids. We will be initiating them randomly and making them with different colors. So this can be done by calculating the distance between the points of each and every data points To make it easier to visual, we can just draw a straight line like this. Okay, so connecting two centroids. So one is towards this cluster and another towards this cluster. So two centroids and a perpendicular line to the straight line. All the points that are closer to a particular centroid will be marked with the same color. So here it is in green color. So once we have identified all the points, we can calculate the summation of all the values by using Euclidean distance. This will help us determine which centroid each point belongs to. In this third step, we will compute the average of all the points in the specific cluster, whether it is red or green. Okay, so this is necessary because we need to update the centroid to reflect the new location of the point. Once we compute the average, the centroid will move to this new location and which is somewhere in the center. So we will calculate the distance and perpendicular line again, and you can see that all the points are now towards the centroid. Again, and cluster from the right and the left side of the perpendicular line. Difference: to determine the k value, we use a concept called elbow method, which help us to find the optimized k value. The elbow method involves constructing a graph between the k value and sometime called, which I have already specified, within the cluster sum of square. So where we start with one centroid and iterate from 1 to 10. So that is k from 1 to 10. And here for each iteration, we calculate the distance between each points and the centroid. And in this example, the k value is 1 because only one thing is there, and the distance value will always be greater than 1. We can then observe the graph and determine the k value where this WCSS starts to level off, indicating the optimal number of cluster. Difference: if the k value is 2, there will be 2 centroid. And you can calculate the WCSS value by taking the summation of all the distance with the centroid. And when you increase the k value, you will be able to see that there will be abrupt changes in this value, that is WCSS value. And this is called an elbow method or elbow curve. Difference: k-means clustering involves updating centroids and calculating distance based on that. As k value increases, the distance becomes normal. We need to find the feasible k where the abrupt change happens. So here, of course, this is what. And once we find it, we take it in as our k value. And in summary, we want to find the cluster. We take the k value and initialize k centroids. So we update the centroid by computing the average and finding the distance. We calculate this process until we get separate groups. To construct the elbow curve, we need to check different k value and the WCSS value, which increases the model complexity. Difference: validating cluster model is an important step to access their performance and reliability. And I just specify some common techniques to validate clustering model. The first one, it is all about WCSS. So within cluster sum of square. Difference: compute the WCSS for different values of k. Choose the value of k at elbow point where the decreases in WCSS becomes less significant. Next, it is all about Silhouette score or Silhouette coefficient. Difference: calculate the Silhouette coefficient for each data points and compute the average across all points. Higher the value indicates better clustering. And next, it is all about gap statistic. Difference: compare the within cluster dispersion of the data to a reference null distribution and select the value of k that maximize the gap statistic. And here the Silhouette coefficient. Difference: this is the one is a measure of how well each data point fits its assigned cluster while also being separated from other cluster. It quantifies the quality of clustering by considering both the compactness of the cluster and separation between different cluster. And here I just specify one thing, dear friends. Actually, the Silhouette coefficient or Silhouette score is the metric used to calculate the goodness of a clustering technique. And the value it's range from -1 to 1. Difference, the value closest to 1 indicates that the data point is well matched to its assigned cluster and is relatively far from the neighbor cluster. So this suggests a good clustering result. And a value that is close to 0 indicates that the point is on very close to decision boundary between two neighbor cluster. And here the value close to -1 indicates that the data points may have been assigned to the wrong cluster and is far from its neighbor cluster. Difference, the Silhouette coefficient is computed using a formula that S is equal to B minus A divided by max of A and B. So here we have the exact A, the average distance between the data point and all other within the same cluster. And here the value of B, thus average distance between the data point and all the points in the nearest neighbor cluster. So to obtain the overall Silhouette coefficient for a clustering, you calculate the average Silhouette coefficient across all the data points. Okay, dear friends, let's dive deep into how we can use the k-mean cluster algorithm, one of the most popularized unsupervised learning technique. So to divide a data set into meaningful groups, we are going to use the Euclidean distance functionality. Let me introduce with it. So in our example, we are going to have 8 data points, A1, A2, A3, B1, B2, B3 and C1, C2. Here, let me just assume here we didn't have any centroid is given. So let me just fix our own, that is A1, B1 and C1 are fixed for us as a centroid. Now, we calculate the distance between each data points. So first of all, kindly just observe, we have to calculate each data points with the 3 initial centroids. Okay, so and here we are just going to make use of this Euclidean distance, and kindly just observe the distance here, it is a square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now kindly just observe, dear friends, here we just took the centroid of this 3 cluster, that is A1, B1 and C1 are fixed as our centroid. And here we have the data points, and each and every distance between the data points and 3 initial centroid we have to identify. So what are all the centroid? Yes. So for A1, so this is the cluster 1 and here it is 2, 10. And B1 is our centroid here. So this is the cluster 2 and here it is 5, 8. And the C1 is our centroid. And here this is our third cluster and here the value it is 1 and 2. Dear friends, we want to find the distance between the point A1 and the centroid A1. So as it is itself, so the coordinate it would be, kindly just observe, it is 2 minus 2 the whole square plus 10 minus 10 the whole square. So which it just gives 0. So I just put 0 here. Now let me just calculate the distance between 2, 5 and 2, 10. So the point A2 with the centroid A1. And here, so let I just apply 2 minus 2 the whole square plus 10 minus 5 the whole square. So which it just gives square root of 0 plus 25 which is 5. So I just place the 5 here. So using this approach, we compute the distance from each data point to all these centroids, that is A1, B1 and C1. So kindly just observe, dear friends. So let me just have the distance between A3 and A1. So I just get 8.49. Next it is 3.61. Next it is 7.01 and 7.21 and 8.06, 2.24. Now next, of course, we have to calculate the same thing, distance between A1 and to the centroid B1. So here also the same thing, kindly just observe, we have x2 as 5 and minus 2 the whole square plus 8 minus 5 the whole square. So like this we have to calculate each, and now what we just get, of course, 3.61. Next A2 and B1, it is 4.24. A3 and B1, it is 5. And of course B1 and B1, it is 0. So 3.61, 4.12, 7.21 and 1.41. Okay, now next all the data points with centroid C1. Okay, so let me just have here the distance between each data points and to the centroid C1. So kindly just observe, these are the data points here. 6.71, 5.39, 0, okay, and here 7.62. Now, dear friends, here it is the one we have to calculate about the cluster which is the minimum distance. So kindly just observe, dear friends, when on just taking towards this point, so 0, 3.61, 8.06, yes, here we just go, cluster 1 is the lowest. Okay, so cluster 1 is the lowest. And the next one, 5, 4.24, 3.16. Of course, cluster 3, the distance, cluster 3 is the lowest. And with the same approach, let I just apply to the other one. And here we just get. Okay, so I just show the updated data. So here what we just observe. Now, applying this rule to all the data points. So here we just got the first cluster assignment. Now it's time to recalculate the center for each cluster. So that becomes the new centroid. And dear friends, if the exact point, kindly just observe here, dear friends, here for the cluster 1 we have only 1 point. So of course A1 would be the same centroid for the next as a new centroid also. And here for the cluster 2, kindly just observe, we have 5 points. So in such a case we have to calculate the mean of the x and y values of all the points in that cluster. So here kindly just observe, we have to calculate the mean of this 8 plus 5 plus 7 plus 6 plus 4 divided by 5. So as we have 5 data points. So here our B point. So I have the cluster B here as 6 comma and here 4, 8, 5, 4 and 9 and again it is 6. So this is what our new cluster point. And for the third one, kindly just observe A2 and C1 are in the same cluster. Okay, and here 2 plus 1 divided by 2. So it is 1.5 for the cluster C. Okay, and here 5 plus 2 divided by 2, it is 3.5. So yes, dear friends, these are the exact new clusters. So we now use these new centroids as reference and recompute distance from each data points to these centroids. So what we have to do, yes, we have to reassign each points to the nearest centroid. Okay, now kindly just observe. So we are going to have these centroids like this. So 2, 10, here it is 6 and 6 and here 1.5 and it is 3.5. So this is cluster 1, cluster 2 and cluster 3. So now, yes, let me just calculate the same distance between each data points to the newly assigned cluster. Sorry, newly assigned centroid of this cluster. So observe, dear friends, here the first point 2, 10 and here also 2, 10. So we have the same. And of course, we would have all the same values here because this A1, of course, the centroid is also not changed. So let I just repeat the same thing here. Now, next we just going for centroid 2. So kindly just observe, dear friends, the data point 2, 10 and with the distance 6, 6. When we just apply this Euclidean distance, the distance is calculated as like 5.66. Yes, dear friends, next one it is 2, 5 and 6, 6. That is square root of this distance here. It is 6 minus 2 the whole square plus 6 minus 5 the whole square. So which we just get here is as 4.12 and here it is 2.83 and 2.24, 1.41, 2.00, 6.40 and 3.61. Kindly just observe here nothing is the similar to this. As like A1 here and to the data points and centroid are here equal. So we just got the same data points, but here it is new cluster assignment. And here, let I just go with the same distance calculation. Here, we just get the centroid of point 1.5 and 3.5. And we are calculating the distance to the data points here. All the data points. So, we just get, yes. Now, let me just go with this calculation and kindly just observe once on updating this. So this is what our second, that is newly assigned cluster, and we have updated all these values of distance. Now let me calculate the minimum distance of it. So here again the 1 and here also it is 1. And kindly just observe this is 3 and of course 3 here. And here it is also 2. And when on just making this is 2, again we are just going to 2 here and here also it is 2 and here kindly just observe it is 3 and here it is 2, 3 and 6 of course 1. So we are able to observe a changes in the cluster. If we might notice the some point changes, of course we have to repeat it again. What we have to repeat? Of course, now with this new cluster, we have to identify the k-means, that is new centroid, and we have to calculate the distance between these data points and the new centroid. Okay, now let me calculate the new centroid. And coming to the centroid, kindly just observe, in the cluster 1, we have 2 data points. So cluster 1, we have data points as like A1 and C2. So with that 2 plus 4 divided by 2. So here we just get 3 as our x1 and here 10 and towards the 9. Kindly just observe 10 plus 9 it is 19 and divided by 2 it is 9.5. So this is our A1. So this is our A1 centroid 1. And next, kindly just observe for the cluster 2, we have 4 points now and with the mean value of 8, 5, 7 and 6. So here the B1 here we just get 6.5 and 5.25. And kindly just observe for this A2 and the C1 we have the mean. Of course, we have the same mean value, that is C1 here it is 1.5 and 3.5. Now, yes dear friends, with this new centroid, let I just apply the new centroid and to this cluster value first of all. So kindly just observe. So here it is the new centroid A1, new centroid B1 and new centroid C1. So here we have 9.5 and 6.5. Here it is 5.25, 1.5 and 3.5. And of course, what is the current cluster? Here we have the current cluster. So this is 1, 3, 2, 2, 2, 2 and 3 and 1. Okay, now what is next? Of course, we have to calculate the distance between these data points towards the centroid of each cluster. And kindly just observe, dear friends. Let I just place the exact value of this. And dear friends, when on just observing, so let me just calculate the new cluster, whether is it any changes or not. So in such a case, so kindly just see here, this is the minimum, so 1. And here we have the 3, so no changes. And here it is the 2, so there is no changes. And here we have 1, of course we have a change, and 2, and this is 2, this is 3, and 1. So what's now? Of course, as we had a change, we have to repeat it again. So in such a case, yes dear friends, so for that, let me just identify the new centroid. So new centroid A1, kindly just observe. So A1, B1 and C2, these are my points, and taking the mean value for this. So 2 plus 5 plus 4 divided by 3. So I just get 3.67. 10 plus 8 plus 9 divided by 3. So we just get 9 here. Okay. And further for B, so centroid B, that is 1, 2 and 3 data points. And with this 8 plus 7 plus 6. Okay, 8 plus 7 plus 6 divided by 3. So I just get the new centroid B1. It is 7, 4.33. And to the last C1, centroid C1, of course, there is no changes here. 3, 3. So it is, we have 1.5 and 3.5. So now what's the... Yes, dear friends. So with this new centroid, let me just calculate the data points of all and let me calculate the distance between each points. So yes, here we just go with that is centroid A1, B1, C1, and I just apply the new centroid here. It is 3. I think it is 6, 7, and here it is 9. 7, 4.33, 1.5 and 3.5. And current cluster value also I just specify. It is 1, 3, 2, 1 here. 1 and next it is 2, 2, 3 and 1. Okay, now applying to the Euclidean distance, let I just calculate the distance between A1 and to this centroid A1, and when on just updating. So kindly just observe here, when on just using this, so these are the exact value. Now observing the minimum value, kindly just see here, this is the lowest, yes 1, and here this is the lowest 3, and here 2 is the lowest, and 1 is the minimum distance, and here 2 is the minimum distance, and of course here also 2 and here also 3, it is 1. And observe dear friends, there is no point changes in cluster anymore. So here that's the algorithm converges. Once there are no more changes, we finalize the cluster. Yes, here in our example. What happens? So kindly just observe. Here we just got 3 cluster, and cluster 1, cluster 2 and cluster 3. So here the points which we just identified is A1, B1 and C2, and here in cluster 2 it is A3, B2 and B3, and here cluster 3 we have A2 and C1. So that's how the k-means algorithm using Euclidean distance works, by repeating these steps until cluster stabilize. And here you would have some doubts. When to use this k-means cluster? Yes, I just specify you the important points, dear friends. Kindly just have a note on it. If you have a well separated cluster, kindly just make use of this k-means clustering, which performs well when the cluster in the data set are well separated and have distinct boundaries. Dear friends, the algorithm aims to minimize the within cluster sum of square, that is WCSS, making it effective in identifying compact and spherical cluster. And the next one, of course, if you have a large data set. Yes, dear friends, k-means clustering is computationally efficient and can handle large data set with a reasonable number of clusters. It's scales well and is suitable for application where efficiency is important. And next one, it is all about predefined number of cluster, that is K. So K means requires the number of cluster K to be specified in advance. So if you have prior knowledge or a specific requirement for the number of cluster, K means can be a suitable choice. And next, it is all about numeric data. Yes, dear friends, K means cluster works well with numeric data. As it relies on calculating distance between data points, it is suitable for continuous variable or attributes that can be represented numerically. And next, of course, quick prototyping. Due to its simplicity and easy of implementation, K-means cluster is useful for quick prototyping and exploratory data analysis. It can provide initial insights into the structure of the data and help in forming hypothesis or making initial observation. And last but not least, yes dear friend, initial cluster center. So if you have some prior knowledge or reasonable estimation for the initial cluster center, that is K-mean can converge faster and produce more accurate result. So this can be beneficial in case where you have some understanding of data or domain expertise. And here we are in the last, dear friends. Yes, clustering algorithm are a valuable tool in machine learning for grouping similar data objects. So the selection of most suitable cluster algorithm depends on various factors such as data size and dimensionality, the desired number of cluster and available computational resource. Two commonly used algorithms are K-means and hierarchical cluster. So each with its strength and weakness. By considering the pros and cons of these algorithms, their practical applications and the influencing factors, you can confidently choose the optimal clustering algorithm for your specific task. And yes, dear friends, that's the K-mean in action. So simple, initiative and powerful. If you found this helpful, give it a thumbs up, share it with your friends and don't forget to subscribe for more such breakdowns. So hit the bell icon so you never miss any updates. And here we go, dear friends. Keep exploring and happy learning, dear friends. See you in the next video.